This balloon racer sample file was designed in Tinkercad and previously sent to Fusion 360. We're now ready to refine and modify the model with Fusion 360's toolset. I'd like to make this design ready for 3D printing. Before we get started, let's right-click on the top-level assembly and select Capture Design History. This will turn on the parametric timeline and record all of our steps, allowing us to update features and dimensions later. We can use the Offset Face command found in the Modify menu to increase or decrease the size of existing 3D bodies. Let's increase the size of the wheels. Start by selecting the outer face of each wheel. You can use the view cube to reorient the model as needed. Once selected, I'll define the offset as 4 mm. Notice this increases the outer diameter of each wheel. We can also use the Offset Face command to add clearance between the axle and the car body. I'll hide the wheel and axle 3D bodies by selecting the visibility icon in the Fusion 360 browser. With Offset Face active, select the two inner cylinders. We'll define the dimension as negative 0.1 mm. The minus symbol will ensure we subtract from the existing 3D body. If I turn the axle body back on, you'll see there is now a clearance between the two parts. I'll also add a small clearance to the inner cutout on each wheel. I'll hide the axles and turn all 4 wheels on. With the Offset Face feature, we'll select the 4 inner faces of each wheel. Once all 16 faces are selected, I'll define this offset as negative 0.05 mm. This provides us with a total offset of 0.1 mm since it's going in both directions. To reduce some of the friction on the wheels, we can add a beveled edge with the chamfer tool. Select chamfer from the Modify menu. We'll then select all 8 edges of the wheels. Looking at the car from the front view of the view cube, I'll test out some different chamfer values. 1 mm appears to give us the desired result as the wheels will be 3D printed lying on their side. This 45-degree angle can be 3D printed without any issues. Notice our features are being recorded in our parametric timeline. At any time, we can double-click to edit an existing feature, allowing us to change the value. While chamfer applied a beveled edge, we can use the fillet command to apply a smooth rounded edge to any sharp corners. Fillet is also found in the Modify menu. Once active, we can select any of the sharp edges. I'll start by selecting the 5 vertical lines on each side. Use the view cube to reorient the model as needed. I'll also select the top edge before defining the fillet as 5 mm. In the fillet dialog, we can add a new selection set, which allows us to add additional fillets with a different radius. For example, I'll select the sharp edge near the front of the car, defining this as a 20 mm radius. At times, you may find it works best to apply additional fillets with a separate fillet command. Let's click OK to save this one, and we'll reactivate the fillet command. This will help us avoid some common fillet errors where the radius cannot be applied due to the surrounding fillets. This time, I'll select all of the remaining sharp edges, followed by a 1 mm fillet. Lastly, I'll add a new selection set with a 0.5 mm fillet to the top of the balloon holder and the opening. The overhang of the balloon adapter may not print well in its current state. Let's double-click on the original chamfer in our timeline. This will allow us to add a new selection set, and we'll select the bottom edge of the adapter. I'll define this chamfer as 1.5 mm. We could also offset the face of the stem, making this larger for the opening of the balloon. I'll offset this outer face by 1 mm. Our car is just about ready to 3D print. The last thing we may consider is reducing the weight of the 3D print by hollowing out the underside. This will help ensure the car can be moved by the balloon. Fusion 360's shell command, found in the toolbar or the Modify menu, helps us hollow out existing 3D bodies. Start by selecting the bottom face of the car body. We'll then define the desired wall thickness, such as 1.25 millimeters. If you receive an error message, try using a different wall thickness. Notice this removes all the extra material beyond the defined wall thickness. We will have to 3D print this with supports. However, the reduced material will ensure the car is not heavier than the balloon can handle. Our balloon car is now ready to 3D print. In less than 10 minutes, we were able to refine and modify our Tinkercad file using Fusion 360's design tools.